Hi, I'm Biff Turkelman. You've seen me in such fine quality, epic chemistry educational videos such as Whitney Houston and Where Do Electrons Hang Out? And Electrons Have Addresses? Part 2. Okay, general chemistry. That's what this whole idea is. You guys are having a quick review about Chapter 4B, what would be important, what would not be important. So, we're starting. Okay, you should know this slide right here. You should know the 4 parts, okay? The first part is your basic energy level. The second part is your S, P, D, or F. Your third part is how is that orbital, that sublevel orbital, arranged in 3D space. Think P in the X, P in the Y, and P in the Z directions. And then last but not least, remember that the electrons have to spin opposite of each other. That would be kind of important. All right. So, your basic energy levels, level 1, level 2, level 3, level 4, level 5, and so on. Okay, so let's move on. Okay, azimuthal quantum number. Guys, think, what's the sublevel? What is the sublevel here? That's the second part of the address. Notice where it says SPDF right here. That's what you need to know, SPDF. Absolutely. Okay, what's SPDF? Well, remember, it's talking about the shape of the sublevel orbitals. Okay, that's a key thing. I would want you to know what the S orbital looks, the S sublevel looks like, and the P sublevel looks like. Okay, now you got only one for the S, and then you have 3 of them for the P. Why are there 3 for the P? That's because it's arranged in 3 different ways. There's the X direction, the Y direction, and the Z direction! Okay, moving on. All right, let's move on here. I am not worried about this slide, so don't worry about this slide. Orientation. You see our hero, Ash Ketchum. Gotta catch 'em all. Okay, P in the X, P in the Y, P in the Z. Okay, Polly. Yeah, homeboy! Hey, homeboy! Okay, let's take a look. Hey, Polly, you're looking like the man, yo. Yeah. All right, remember what Polly said. He said, you can't have 2 electrons in the same spot. Oh, sorry, I'm in the wrong spot. Let me go over here. And they got to spin opposite of each other in order to stay stable. That would be important. Paulie looks like he's about to go start a fight. Okay, the spin, we got that. We got that. We spin. So electrons have to spin either this way or this way in order to make things happen. Now, of course, the question is why? Well, hey, I think Morpheus from the movie Matrix has got it. Take a good look right there on 3, 2, 1. Moving on. Okay, do not worry about this slide. It is just a review of the 4 pieces of information as to where the electron is. Now, look at the S sublevel. This is what the S sublevel looks like. All right. No more than 2 electrons, according to Pauli, and they have to spin opposite of each other. So one electron does this, the other electron does this. Okay. Then we have the P sublevel. Now remember, there's 3 of them in the X. That's the X. Then there's the Y. Notice I'm forming the X and the Y, and then, of course, the Z. So let's try that again. X, Y, and the Z. Surprise, you didn't think I'd do that, did you? All right. D sublevel. D sublevel, you got 5 orbitals. That means there's 2 electrons for every orbital. So the maximum number of electrons we can fit in the d sublevel is going to be how much? Let's see. 5 times 2. 5 times 2 means you got 10! 10 electrons, and they're all spinning opposite of each other. Ah! Okay. F sublevel. 7 possible orbitals, up to 14 electrons. Wow! What can I say but, dude, 14 electrons? Put me in the spotlight. Yeah, put me in the spotlight. Woo! Okay. 7 possible orbitals, 14 electrons, and guess what? They all gotta spin opposite of each other. Ooh, some people are going to say, I'm going to have a headache when you keep spinning this way. But that's what electrons do, boys and girls. They all do it. Every single one. Okay. Am I worried about this slide? No. Am I worried about this slide? No. Am I worried about this slide? Yes. What's the idea? That first idea right there. Look, the higher the energy level you go, that sublevel is going to get bigger. Okay? So 1s is going to be smaller than 2s. 3s is bigger than 2s and 1s. Okay? And 4s is bigger than 3s, that's bigger than 2s, that's bigger than 1s. And guess what? Same thing for the p orbital, same thing for the d orbital, same thing for the f orbitals. The higher the energy level you go, the bigger those sublevels are going to be. They're going to take up more room. That's just the way it is, with the electrons spinning around in there, clockwise and counterclockwise. You know that. Yeah. You know it. Because it's true. Alright, let's move on. The order in which electrons fill. Okay, this would be kind of important. Because you got 1s followed by 2s. Notice where the arrows are going. So our first arrow goes through 1s. Great. Okay, then the second arrow goes through 2s. Alright. Now if it helps you, you can always draw like a little line and go, you know, up like this. Ooh, hey. Whoo. Oh, what do you know? Okay. So you can spin it. Alright. You can spin it. You can have the line go back and go to 2s, go back and through 2p and 3s, and then 3p, and then not 3d, remember that, 4s. Well, what is up with that? Well, we're going to get into that today. Am I worried about this particular thing right now, this picture? No, I'm not. Okay. Atomic number. Oh, my Lady Gaga, critical! Ah! Okay? And some people are saying, Canu, I'm getting tired of your antics. Well, I've got the video camera and I can do whatever I want! And it's a review. You need it. And I'm trying to help you out because I don't have to do it. So, think about it that way. Yeah! Woo! All right. It ain't easy being Grandmaster C, yo. All right. Seriously. Atomic number. Atom's identity. What's the atomic number? It's the number of protons in the nucleus of the atom. Am I worried about neutrons with the atomic number? No. Just the protons. Now, there is a key thing. If you look on the top of the slide here, where it says, in neutral atoms, the number of electrons equals the number of protons. They're equal. Okay? So an atom does not have a charge. It's not positive and it's not negative when electrons and protons are equal to each other. Okay? That's just the way it is. Now, the periodic table is arranged by atomic number. I am not worried about that. The atomic number is important. The neutral atoms, how is that neutral? That's important. Those two ideas, the one right up here, the first line, and then the last two lines here, that's important for the review. Okay? All right, I got to keep going. Okay, off bow. Remember what I said to you guys about off bow? I did not like this definition. Look, electrons are going to fill the lowest available energy level. That's it. The lowest available energy level. That's what the electrons are going to do. Okay? What is a student going to do to complete the assignment? Are they going to take the easy way or the hard way to get the A? They're going to take the easy way to get the A. Electrons are going to go to those levels that have the least energy in them. That's why if you look here, it is easier for the electron, instead of going to 3D, even though it's on the same energy level as the 3s and the 3p, the 4s is a little bit less energy than the 3d. That's why the 4s will fill up first. Okay, now how far up this 1s and 2s and 3s am I expecting you guys to do? I would expect that you guys should know the 1s, the 2s, the 2p, the 3s, the 3p, the 3d, and the 4s. And the 3d. That's it. That's all I would expect you to know. Anything above, 4p to 5d, no. No. Okay? I'm not having you guys memorize this. Electron configuration. Yes, I'll guarantee you it's going to be on the quiz. You should know what the 1s1 means for the hydrogen. You got basic energy level, your principal energy level 1, sublevel S. Okay, it only has that one orbital, that's sublevel S, and then the 1 refers to how many electrons are in there. Okay, how many electrons are in level 1, sublevel S in the hydrogen atom. Okay, and this is for lithium, and I did not talk to you guys about the He. I am not worried about that here. Okay, I'm not going to get that complicated with it. Now, what's the difference between electron configuration and orbital notation? Electron configuration is the 1s1, 2s2, 3s2, 2p6. Those are electron configuration. Now, the orbital notation deals with the spin of the electrons and how that arrow is placed, like you see here on this. See underneath this 1s, you got the arrow going up and the arrow going down. Now I realize some people would say, but that looks like a 1 or a half arrow. Can I draw a complete arrow? Sure you can. No big deal. Hund. Remember I talked about the monopoly rule, okay, with Friedrich Hund. Okay? Here's the thing. Let's look at 2p. If I have got 3 electrons and I need to fill 2p, level 2, sublevel P, remember 3 orbitals, P in the X, P in the Y, and P in the Z, and I've got 3 electrons. Each electron needs to go into one of those P orbitals. So 1 in the PX, 1 in the PY, and 1 in the PZ. That's it. That's basically it. Okay? That's Hund's rule. One last slide. Yay! Okay, here we go. Oops, that's not it. This is it. This is our last slide here. What is this? This is showing you the order in which electrons are filled. You may remember that paper I handed out to you guys. This is similar to the paper, except it's got pretty little colors. So here's 1s, and here's 2s, okay, 2p, 3s, 3p. Now take a look at this. Here's 3d, here's 4s. Now if you look here, excuse me, this is the energy that's involved. If you look here, the 4s is just below the 3d. Okay, because it takes less energy for the electrons to go and fill 4s, then go and fill the 3d. Okay, that's basically it, ladies and gentlemen. That's it for the review, and I am running out of time. So, I'm signing off. Good luck.